In the last video, we understood the networking basics related to IP addressing specific to version 4. Now in this video, we'll try to understand the VPN and VPC concept, which are quite useful when configuring CloudHub. Let's take an example of a smart home network. I have a laptop, a smart TV, a smartphone, and a smart refrigerator. Now, to leverage the smart technology of these devices, they should be connected to a network so that they can communicate with each other. So here's a router that can create a network and provision a communication channel for all of these devices to communicate with each other. Now, each of this device will have a network address. Also, each device needs to open up a port either to listen or to request. For example, this laptop is most likely having a web application and it's serving web pages at port 80, hence it has opened up a port 80. So it's listening on port 80. Similarly, this smart TV is listening for request on port 7001, and the request could be to turn on the TV, turn off the TV, change the channel, increase the volume, decrease the volume, and so on. Let's go to the refrigerator. Again, the refrigerator is also listening for requests on port 7003 so that it can turn on, off, or maybe regulate the temperature. Now, this mobile is not listening for any request. Instead, it is requesting a web page for this on this laptop. So let's take it this way. This laptop is having a web application that can track the status of the devices in this network, specifically the smart TV and the smart refrigerator. This application can also turn on, off, increase volume, decrease volume, change the channels on the television, and it can do the same thing, similar things on the refrigerator. So this web application has that feature implemented. Now, a mobile application, I'm using this mobile and I want to access this web page on the mobile. So most likely I'll enter the URL of this laptop, which is 192.168.0.52, and the web browser will open up a page hosted by this laptop. So whenever I request anything over the network, I also have to open up a port. So here the laptop is requesting, even though it's requesting, it's opening up a port 7002. So it's requesting a web page. So it requested a web page to the uh, laptop, and the laptop has served the web page. Now, if it wants to control the TV, it can do using the web page available. So that's the overall idea. We have all the four devices and we can control the smart TV and the refrigerator using the web application hosted on the laptop. So until now, I was able to control the smart TV and refrigerator through my smartphone using the web app hosted on the laptop. Now let's slightly change the scenario. Assume it's summer and I plan a short vacation to a nearby hill station. As a result, my smartphone moves out of my home network. But I still want to control my devices back at home. So I turn on the mobile data and get connected to my cellular network's internet. This involves getting an IP address for my smartphone. Once I have this cellular network on, I enter the address 192.168.0.52 in the web browser and click OK. But unfortunately, it doesn't work. But why would it not work? The reason is that the IP address that I entered is a private IP address and it's not routable over the internet. But I still want to control the devices back at home. How do I attain it? Now, to do that, the router back at home needs to have a public IP address, and this can only be done when the router gets connected to the internet. So I get a connection from the ISP, connect to the internet, and my router now has a public IP. Now back on my smartphone, I enter the public IP in the web browser and click OK. Again, I am still not able to access the desktop. Now there could be two possibilities here. First, we need to understand that the devices connected to the router are known to be in a militarized zone, which means that any external traffic trying to reach the internal devices will be rejected right away. Now, when I enter the public IP address in my mobile phone's web browser, there could be two possibilities. One is that the router will reject the request right away. Second, if at all it's listening on port 80 for external request, it will show up a login page for the router's settings. So basically you can control the router from there, but you cannot access the devices inside the router's militarized zone. Now, if I still want to get access to the devices, what I would need to do is port forwarding. Now, using port forwarding, I will forward any requests coming on the public IP address of router's port 80 to the laptop's port 80. This is a setting which has to be specifically done on the router. Once I do this, I should now type in the IP address, the public IP of the router, click OK, and now if you observe, the request can successfully be sent to the laptop. Now, one thing to note here is that the IP address that the router has needs to be static, because any ISP will provide an IP, will lease out an IP address from its pool for most likely 24 hours, unless and until it's not static. If the IP address is static, it remains with the router forever. And this releasing activity of the IP is done in order to save the IP addresses. Alright, so after having a good vacation, I am back at my home, and so is my smartphone. It's now back in the home network, and now it doesn't need any public IPs to reach out to any other device in the network. It can right away use the private IPs. But I enjoyed the nearby hill station a lot and thought of purchasing a house over there. And I went ahead and got a house, and now even that house has a smart TV and a smart refrigerator which I want to connect. So in order to connect or control the devices, I created the same network in the hill station house. It's just that this house doesn't have a laptop which has the web app that can control all the devices, and of course my smartphone remains with me, so it's in the home network. And the other network, the hill station home network, only has two devices, a smart TV and smart refrigerator. Now if I want to connect to it through my first network, it should only be possible via an internet connection, because this is a different network. Again, this is a private IP address. The TV has a private IP address of 192.168.88.2. So even if I enter that IP address, traffic could not be routed because the message would first go to this router, and this router would realize that this is a different network because this one has 192.168.0 and this one has 192.168.88 as the network portion. So both are different networks. So it will uh, obviously send the request to the ISP and it will get rejected right away because it's a private IP and it's not routable over the internet. So I eventually connect the second network to the ISP, and now this network also has a public IP. Now the other thing that I'll have to do is forward the port 7001 of the router to 7001 of the smart TV. And same for 7003 of router will be forwarded to 7003 of refrigerator. We don't need to forward port 80 because there's no laptop here. We only have a TV and a refrigerator listening to port 7001 and 7003. So this laptop needs to communicate with these two devices, right? So we need to forward traffic coming on 7001 and 7003 to smart TV and the refrigerator respectively. Now, even if I again try to just enter this 192.168.88.2.7001, that won't work because again it's a private IP address, right? So what I'll have to do is if I want to control these devices, I would need to configure in this web app that this web app needs to call the public IP and the port 7001 so that this router will forward the traffic to the smart TV or the smart refrigerator based on the port that I have invoked. So I send the request, I use the public IP and port 7001. So the request reaches to the smart TV and now I can control it using this laptop. All right. Now this looks good, but take a scenario. There is another guy on the internet and he has been scouring the internet to find out devices with exposed port which have open ports and are listening actively. For example, this router has port 80 opened. This router has port 7001 and 7003 as well as port 80 opened, right? So this router is exposing three different ports right now. And this external user, I don't know, he is some stranger and he just finds out he is scanning the IPs and the ports and realizes that this IP has port 80 open and this public IP has port 80, 7001 and 7003 open. What he does is he tries to access port 80 of my home network. And what would happen now? It would reach the router and the router will eventually forward the request to my laptop. And this guy will now have access to the home page from where I can control all the devices. Same applies for the second network. He gets the public IP, uses port 7001. He realizes that 7001 and 3 are open. He uses that and he gets access to the smart TV and smart refrigerator as well. In short, what I'm trying to say here is that the external user is now able to access my militarized zone. My security is compromised. He has entered into my network, both the network A and network B, which is a security risk in this case, right? Because, and the reason why it happened is I exposed or I did opened up port 80 and also forwarded it to the internal network. Hence, this security threat has come into picture. So in order to access the devices in home A and the hill station home, we unfortunately exposed our network to attackers by using port forwarding options, which is a bad idea because it gives attacker a scope to exploit any vulnerability inside the network. And the attacker, if he has control of one of the device, he can easily get control of all other devices, and there's a lot of scope to do any damage to our systems or any steal any information. So this is certainly not a good idea. Now you might argue that you can probably put a login page to with secured with a username and password, but that's just for the application. Now there could be some more exploits that you are not aware of, but the attacker might be, and can easily leverage those attacks and get access to all of the systems in my home as well as the hill station home. So this certainly is not a good idea. So how do we fix this issue? I don't want to do port forwarding, but I still want these devices to be accessible and should be able to communicate with each other as well. And this should not be accessible externally. At least as long as I'm in the network, in my first home network, I should still be able to connect to the second home network. And same applies for the second home network. Even that should be able to communicate to the first home network. So how do I facilitate that? So simple option would be take a cable and connect both the routers with each other. So this sounds theoretically correct. What would happen is, like, I would take a cable and link both the routers, and having that would connect each other. So if I send any request, I should be able to access the devices on the other network. So this sounds good, and this should help us. So what I will do is, once I have this cable connected, both the routers connected, I'll just disable port forwarding because I no longer need port 80 to be forwarded to this port, and similarly 7001 and 7003 port, because now, since I've connected both the routers using a physical cable, right, I can directly access these devices using the private IP. I no longer need the public IP. And since I've also disabled the port forwarding of port 80 on first home and port 7001 and 7003 on the hill station home, none of the user outside the networks can access. So I basically created a private network. So how will this work? Now if I want to send a message from laptop A, I should be able to send it to laptop to the second device. Since we have disabled port forwarding on the router of home and hill station home, it's not possible for anyone outside the network to enter, because any request coming in would have two possible options. One is the router, if it has port 80 open, it's not forwarding anymore to internal. So it will greet with the web page of the router, or else if the port 80 is completely shut on the router, if it's not listening, the requested gets rejected right away. So now same would happen with this attacker trying to attack. He sends a request on the public IP of this router, and if the router has shut down its port for external access, which most probably is on most of the routers, the request gets rejected right away. Same is the case for the other home. The hill station home will also reject all the request. So in this way, we have prevented any external attacks into our system. Now, a couple of points to notice over here. First is that both the routers are connected with a physical cable, and hence they are forming a private network, due to which they are able to communicate. The devices in the network are able to communicate with each other using the private IPs present. The another thing is, it's not practical at all to connect both the routers with a physical cable if they are separated with geographical boundaries. So imagine if both the routers are at a distance of more than 1,000 miles apart, right? So theoretically it's possible, but practically, if you try to lay down a cable, that would cost you lot of money, right? And if there are, I mean, in the world there are quite a lot of organizations which might try to connect their two offices, and if they use this physical, I mean, if they take the overhead of laying down all these physical cables, it would be quite impractical. They'll have to invest a lot of money into that. So this is not at all practical. Now other thing is that the IP address, had this router got the same IP as the one configured here. So if this router also had 192.168.0.1, this would have been an overlap, because now it's difficult to identify each other, right? Or let me simplify this. Now let me keep this as 192.168.0.56. So it's 54, this becomes 56. But this one has the same IP address as this smart TV in home network, right? So it has 53. So now if this guy will enter 53, it will reach this smart TV and not this smart TV. So this is the problem with IP overlapping. So you should always ensure that IPs should never overlap. They should be different. So here the network portion is 192.168.0, and here it's 192.168.88. So each devices in the network are uniquely identified with the IPs. It's not overlapping. Overlapping is as good as two different home are having the same address. So it gets confusing, and then it leads to uh, wrong results, right? So since having this private cable is not feasible, and with the help of this private cable we were able to create a private network. So it's a physical private network, and since this is not feasible, what we can do is we can use the existing ISP service, which means that we can use the internet and create something virtually, and that creates a virtual private network. So what really happens in this virtual private network is that there is a VPN gateway that takes care of assigning the IP addresses to any new member joining the network, and the VPN takes care of making both the routers part of the same network. It creates an internal network that cannot be accessed externally unless and until that device becomes part of this network. Okay, so that's taken care by VPN gateway, and also any traffic going out of this network is completely encrypted. Now this encryption occurs on top of the HTTPS encryption which is already in place. So that's the amount of security it gives you. Now since these two home are my site, I can call it as site A, site B. So site A and site B are connected with this VPN. So it is also called as site to site VPN. Similarly, if I have a mobile device which is out of both the networks, for example, I am out of my home and I'm at some other place, okay? And if I want to connect to the system, obviously I cannot directly access over the internet because ports are now blocked. So I'll have to be a part of this network so that I can use the private IPs to call. So what can I do? I can use a VPN client and connect to the network, to my home network. And then this VPN gateway will assign me an IP address which is private, but that can connect to the system. So again, even now I am also part of this network. So now I can easily connect to any of the machines as required. So this is also known as client to site VPN. So now I feel that the app I created to control smart devices at any home has a lot of potential to be commercialized. So I am thinking of creating this application as a SaaS product. But unfortunately, I don't have the resources to do, I don't have the compute power and the scalability to do so. And I'm not at all interested in taking the overhead. I am interested in just creating, developing this app, or maybe even configuring for my customers and adding some improvement. I don't have the luxury of time and also money to uh, host this application on my own for my customers. So an idea comes to my mind, and I have a friend who has a lot of computers available. Okay, and he doesn't use it much. So what I can do is I can reach out to him and ask him to host my application, and people out there can leverage it. So basically it is cloud. So cloud is nothing but it's a data center, all right, which is hosted by some other party, so third party, and they have all the required tools using which they can scale the application and do all sorts of things which are required to run uh, an application. All right. So what I do is I basically shift this application to the cloud. So I've removed the computer from here because I don't want to host it on my own premise. So I moved it to cloud. So assume that this is the laptop which has the application. So this server is having the application. But there's a problem here. The problem is that there could be multiple different computers or servers in the cloud, and each server might be hosting some different app. And due to this, there could be a possibility that they are connected to a single gateway, an internet gateway, or assume it as it to be the similar network, right? Connected to with a router, right? So this machine, and this machine, since they are on cloud or on any third party vendor's premise, right? So they should be able to connect with each other. They can communicate with each other because they form a part of a same network. Now, this in particular is a bad thing for me, right? Because if some customer purchases my software and he links it to his network, others might be able to access confidential information on the cloud. So this is not a good idea. So how do we solve this problem? What we can do is we can isolate this machine from other machines, right? We can virtually isolate. Physically we can't, but we can create a virtual isolation, and this machine can have its separate gateway, right? And this is known as virtual private cloud, which means that this machine is separated from all the machines, and it can create its own network. So now the data in my machine is secure, and only I can access it, or my customers who are purchasing the software, piece of software, can access it, and no one else can access, right? But now this is fine. This isolation is good now, creating its own network. But again, I have to connect this machine or the software to my own network. So again, same thing, we have to use the VPN gateway to connect. So we connect the cloud system to a VPN gateway, and now this forms a part of the same network. So this is usually done by VPC peering, which is a sort of site to site VPN, or there could be IPsec tunnel or direct connect. Direct connect is same, it's a dedicated line which can be leased out by the cloud provider to your on-premise system or to your VPN gateway. So this is virtual private cloud. It's just that we have isolated our system from other systems on the cloud. So now I hope that you would have understood the basics of a VPN and a VPC from this slides. Uh, I hope you found this video useful. Thanks for watching.